All right, so we're going to just go over, review some formulas from when you've done like exponential applications, word problems in the past. So here are some formulas, and we'll go over, what the variables stand for. So A of t equals A naught, or A sub 0, 1 minus r to the t. So that is if something is decreasing in value, like depreciating in value, like the worth of a car, maybe a population, I don't know, could be decreasing. So if it's decreasing, you will subtract the rate from 1. The rate will be given as a percent, but you will need to change it as to a decimal. And this would be an annual rate, so once a year. So if it's going down by 10%, you would have 1 minus 0.1 in here, which should make sense because if you're decreasing by 10%, you would have 90% left, or 0.9. And t is the time in years, and a sub 0 is the original amount. Okay, and then from here, if something is increasing in value annually, so a of t, the amount at time t, equals the original amount, a sub 0, and then 1 plus r to the t. And that's if something is increasing annually by a particular rate. Once again, so this has a plus there. The rate you do need to change to a percent. So if it's to a decimal. So if it's increasing by 10%, you would have 1 plus 0.10, or 1.10, which is 110% of the original amount, to time whatever the time is and how many years. Usually it's years, but it could be whatever. So both of those, if it's increasing once a year, or not increasing or decreasing once a year. But let's say interest is compounded a different number of times a year. So 1 plus r over n to the nt. So if interest is compounded twice a year, then n would be 2. If it's compounded quarterly, n would be 4. If it's compounded monthly, n would be 12. So n is the number of times a year it's compounded. So really, this formula here is the same as that formula there, where n is 1, so once a year. And that's because when you're given the interest rate, you don't get the whole rate each time. It's divided equally by the number of times you're compounded. And then here the exponent is n times t. So if you're compounding twice a year for 3 years, 2 times 3 is 6. It would be compounded a total of 6 times. And once again, n has to be a finite number. Let's say interest, though, is compounded continuously. So I could continue with the variables a of t and a sub 0, but I'm going to do p here, or p of t, and p sub 0 e to the rt, because I like to call this formula PERT. But really, it's the same as saying a of t equals a naught e to the rt. And you use these formulas here if interest is compounded continuously, like every minute of every second of every day. R is still the rate, but you do have to change it to a decimal. It is part of the exponent, so it's e to the rt. You have an e button on your calculator. It's about 2.718, but you're not going to round that. You're just going to use the e button on your calculator. Now, kind of a spin-off of that, this is really a specific version of the law of exponential change, which is y equals y sub 0 e to the kt. Now, if k is positive, that means this is an exponential growth situation. And if k is negative, then it's exponential decay. And so really you can see that these are all the same formula. A lot of times you have to solve for k, and then you use that value to then answer the question. And so if k is not your final answer, if you're finding k in order to get your final answer, remember you don't round answers that are not your final answer. So either you keep significantly more decimal places for k, or even better, keep k exact. If k turns out to be 1/3 ln of 4, then keep k 1/3 ln of 4. So just make sure that you don't round non-final answers. And then the last formula, which you may recall, a of t equals a sub 0. So they all have like the starting amount, y sub 0 here, the starting amount. This one's a little bit different, b to the t over k power. So not this k here, totally a different k. So this is if you know that your the amount of money is doubling or tripling, or it's a half-life. B is the number that you're multiplying by. So if it's doubling, you have a 2. If it's tripling, you have a 3. If it's a half-life, it's a half. And K is the time it takes to double or triple or half. So if it's like the half-life is 10 days, then K is 10. Or if it takes 6 hours for the population to triple, then K is 6. T is, you want to know the amount after 3 days or 2 years or whatever. But K is the time it takes to double, triple, half, and that sort of thing. All of these formulas should be a review for you, and you are expected to have them memorized and to know when to use which one. There'll be certain sometimes where there are different options, and then in which case it doesn't matter. But do, especially, probably the biggest mistake people make is between maybe these two formulas here. But just know here, if they talk about, oops, sorry, not those two. Oops. Let's see here. Can I erase? Erase, yes. It's not like the Cami erase. But anyway, so these two over here. Nope. Gosh darn it. One last time. All right, last time. Between these two here. This is if it's compounded continuously. So if you ever see continuously, you should have an E here. This is when it's compounded a finite number of times, n times per year.